Hello friends, good day. Today we will talk on ACF and PACF, autocorrelation function and partial autocorrelation function. These are the topics from time series analysis. Maybe next week I shall talk on time series. So ACF and PCF in time series analysis, when working with time series data, one of the key goals is to understand how current values relate to past values. Two important statistical tools help us to do that: ACF, autocorrelation function, and PACF, partial autocorrelation function. So autocorrelation function is the correlation between the time series and the lag time series by step K. So it helps in detect seasonality in time series analysis. Let us talk about autocorrelation function definition. The ACF measures the correlation between a time series and its lag versions. In simple terms, it tells us how strongly the current value of the series is related to the previous values. That's why it is called autocorrelation. Mathematical form: autocorrelation with lag k is covariance between xt and xt minus k. Xt is the time series with the index t, and xt minus k is the time series with the lag of k, divided by root over variance xt and variance xt minus k. So for lag 0, when k equal to 0, this value becomes 1. Covariance between xt and xt is variance of xt, and root over variance of xt into variance of xt is variance of xt. So the value is 1. For lag 0, the value is 1. The correlation between the time series with itself is 1. For lag k shows how much the series is correlated with its value k steps earlier. So that is the concept of lag. Let us go to the ACF plot. How it is plot: in x-axis we have the lag values 1, 2, 3, etc. Y-axis we have the correlation coefficients between -1 to +1. The confidence band shows the statistical significance. There is a confidence band that comes up with the ACF plot. If autocorrelations drop slowly, the series may be non-stationary. Partial autocorrelation function, PACF definition: the PACF measures the correlation between a time series and its lag after removing the effects of shorter lags. So here the partial correlation is used, but I am not very clear about the formula of PACF. ACF shows the total correlation with all previous values. PACF shows direct correlation with just that specific lag. Correlation between xt and xt minus k, ignoring the effect of other values at different time points. PACF plot. PACF is often used to determine the p and the order p of an autoregressive function p model in ARIMA. ARIMA is autoregressive integrated moving average. So P is the order of the AR part. For ARP process, PACF cuts off after lag P, ACF tails off gradually. So this is the comparison between ACF and PACF. Measures total correlation with past lags. ACF measures total correlation with past lags. PACF measures direct correlation after controlling the shorter legs. Controlling or ignoring. Used for identifying moving average Q terms. So the lag at which the ACF is maximum is used to model the moving average term in ARIMA, and PACF helps in identifying ARP terms. So lag which is maximum PACF identifies the order of autoregression in ARIMA. Patterns of ARP tails off for ACF, and for PACF cuts off after lag P. Pattern for MAQ for ACF cuts off after lag Q, and it tails off for PACF. Applications: ACF helps detect seasonality. Repeating spikes at fixed lags often indicate seasonal patterns. One can detect seasonality using ACF. How the time series data is related to the past values of the time series, same time series data. PACF helps in choosing AR terms used to decide how many past terms should influence the model. So ACF model, maximum ACF gives us the moving average order, and maximum PACF value gives us the AR order, ARQ. This is the data from our friend's cafe. I have taken out the numeric values to keep confidentiality. So this is sales data, and this is the ACF of the sales data, and this blue band is used for statistical significance. If you look, there is no particular lag at which the PACF is maximum. So maybe 1, 2, 3, 4 could be a small and good moving average order for our sales data. And this is the partial autocorrelation function. There is no spike, no distinct spike, and we can take again 4 as the order of the AR function in our sales data. Thank you. I'll stop here. Like, comment, share and subscribe. I am available for one-to-one discussions too. Thank you.